Good morning, chat, evening, wherever you are. I prepped like all week for this stream. There's a lot. There's a lot we're gonna go through today. Sorry, excuse me. But yeah, so let's talk about what we're doing this stream exactly. So first of all, earlier this week, was it this week? I think it was this week. I was looking at a .NET ahead of time compiled application, and usually it's not that bad. You know, usually I could still make out the structures and whatnot. But this time I was like, oh, is this even .NET AoT compiled? I was like, am I getting rusty? Because like I looked all around. Previous indicators for what would be a .NET ahead of time compiled application was not there. You know, I usually expect like a .NET Core app version number in there. Usually expect a few AoT related compilation warning text in there. There was none. In fact, let me go to wait, I'm not connected to the internet. Hang on. Here. Let me open the recent PR that I did. If it loads. There we go. Yeah, here. So in the previous versions of ahead of time compiled applications, I expect strings like these. You know, there'd be a .NET Core app, comma version equals something, or AoT related specific strings. But no, those weren't there anymore. And I did notice that there was an export header, export function name called .NET Runtime Debug Header. I was like, this doesn't look like any of the .NET AoT compiled application I've seen before. And so I looked around a little bit more. Turns out that is .NET AoT compiled. This started to become the case. Well, first of all, I apparently missed this last time I was looking at .NET AoT compiled application. Apparently it started showing up since .NET 8. But point is, yeah, .NET 10, this rule just does not work anymore. None of the strings in here were referenced in the .NET 10 compiled application. So I had done a little bit of preliminary study off stream to figure out what's going on, and I have established a few things that I'm gonna get to in a little bit. But first, let's just assume that we know nothing about .NET AoT, and so let's start from the very beginning by going to this documentation. So, for those who have not used .NET in a while, let's talk about first of all the usual way that .NET Runtime works. So, .NET Runtime, as you know, it's usually JITted. It's just-in-time compiled. So, all of your things are in your application. You might notice that if you compile a .NET application, your application will be pretty small by default. So if we go into if we make a hello world, for example, and we do .NET new console, and if we do a .NET publish-c release, go into bin, release, .NET 10, publish, you'll notice that your application tends to be very small. In fact, it can even be smaller. Oh, thank you for follow. If you publish as a .NET FX or something that targets .NET Framework, they'll be even smaller because all the runtime is already built into Windows. So you don't need to do any of that. That's the advantage of being JITted. It's that there's not a lot of information that needs to be stored in an executable because the runtime itself is already stored in either Windows or in the case of .NET Core and onwards, all of that is stored in the .NET Runtime thing that you install separately. And so realistically, what's inside a typical .NET compiled application is you'll see something called IL, intermediate language. Basically, instead of compiling two native instructions, so they get compiled into something called IL. And for the IL bytecode, there's not a lot that needs to be in there. Like, for example, if we open this up in dnspy. Do I have dnspy here? I don't. Let's install that real quick. dnspy. If it loads. Oh, I guess I do have dnspy here. Hang on. Oh. Yeah, I'm just stupid, I guess. Will this even work? Yeah, there needs to be a newer dnspy version. Oh, it's crashing. I think it's because it's targeted for CET. We need to grab a different version. We need to grab the .NET-FX version. Oh, here we might need to target .NET-FX instead. Codium. We will target net 4.5. Do I even have the .NET 4.5? Oh. We'll do... I mean, we don't need nullable. Let's just turn that off. Fine. Oh my god. We'll use language version higher than that. What was it? Language version? Can you build .NET 10 and use dnspy framework version? Yeah, technically, I'm not sure actually. You used to be able to with just .NET 10. Wait, hang on. I mean, it shouldn't matter really, because dnspy should work across the different builds that it's compiled for. Language, C#. It's been a while since I last wrote in C# and .NET in general. Language, version, .NET, rather C#. You get the idea. How do I specify this in CS Proj? Lang version, that's it. We'll just use latest. There we go. So yeah, this is what a typical .NET compiled application would look like. You'll see that it's very small in size because it doesn't need to store anything really. It just needs to store the relevant IO instructions, which is not a lot. And you can see the instructions by going to the IO view. You'll see that it's basically just these. 72 refers to LD string, 28 refers to call, 00 is nope, 2A is return, etc., etc. So if we go back into, if we go back to the documentation for AoT, so the idea of AoT is that, first of all, let me take a sip. So there was an advantage for using JITted runtime. The main thing is that it's portable across different architectures. As long as the runtime runs on the target architecture, then the developer doesn't need to worry about whether or not the app will run on the target architecture. And the problem with that is that JITted code back in the days, it used to be considered that JITted has the possibility of running better than native applications. However, there are a few problematic things about this approach. The first is that, as is often the case, the native code tends to actually runs better in some cases, but the best thing about it is usually the memory footprint. If you compare a JITted version of a standard .NET runtime application, and you compare that to a AoT compiled application, you'll notice that memory footprint is significantly smaller because it doesn't need to load all of that runtime at once. It just needs to load, the actual executable itself. And another thing is the problem with the .NET approach is that the runtime is JITted, right? You cannot. There are some platforms that restrict the usage or ability to use anything that is JITted. So, for example, on iOS. On iOS, famously, you cannot use a JITted. You cannot use anything that uses JIT. So it's actually described here as well. It can run in environments where JIT isn't allowed. So instead of running it through a runtime that evaluates the IO instructions at runtime, what it does is it pre-compiles all of that and turns them into native instruction sets. Oop, I did not mean to do that. I did not mean to do this either. Please. And this idea of compiling things ahead of time, I think this was first experimented on internally under the project name Project Rover or something. And it was first being used, it was first being shown to developers publicly in .NET version 7. And at that time, AoT compilation was still experimental and is therefore something that is technically unsupported. It was basically like an experimental preview feature. And now it's evolved to the point where it's considered to be stable enough. But there are some quirks about it that we will get to later. But the gist of it is you can now compile AoT applications by specifying publish AoT true in the CS project. So we'll do that. Publish AoT true. And we're going to turn this back to, let's just do .NET 8 for now. And then you can just .NET publish. Oh, wait. Oh, sorry, I just remembered. First of all, remember why this didn't open in dnspy? That's because the main assembly, the .exe is actually a stub to the runtime. The actual code is in the .dll. So if we drop the .dll back in dnspy, as you can see, it'll load just fine. But anyways, we need to turn on publish, turn on AoT. Let's double check if we did that correctly. Might need to be, publish, not public. and it's gonna take a little bit longer. And the thing with publishing AoT is that you'll also need a linker, a C++ linker for this. So we do .NET 10. We'll do .NET publish again. What? No, it should be. Huh? Let me do this real quick. Import module, dev shell, enter vs dev shell. Okay, let's try that again. What? That should be supported. I'm not sure why it's saying that's not. But regardless, we can take a look at the .NET 8 version that we published just now. Go into release, .NET 8, publish. Winx 64, there it is, publish. And as you can see, instead of having multiple DLLs that scatter all over the place, what it does now is that it's compiled everything into one single package, and it's one single executable now. And now it just, the size difference is also drastically different compared to if you just did a single file publish, which basically combines everything that the runtime needs into one single executable. But the difference AoT makes is that it only collects the necessary ones. So we run hello world now, hello world run just fine. We open into dnspy, you'll see that it won't work because it's a native PE. If we open this up in IDA, load the PDB as well. You'll see that, hey, it's in native instruction sets. There's no IL. It's just a bunch of native x86 64 instruction sets. And because of the PDB, so we have the necessary symbols as well to see what's there. Okay, so what are we studying for today? We know how JIT works. We know how AoT works. We know that's a thing. What's the deal? What are we doing today? So, before we go on, we need to solve this problem of where, for some reason, it's not compiling. If we add a runtime ID, will this work? Because I swear it was working before stream. Let's do .NET clean. Oh my god, please. We'll turn it off. .NET clean. Oh, is it .NET 10.0? What? No, Hello World 2. Come on. Oh, it's net 10.0. That is indeed the case. What? What? What's so different about this one then? Oh. Right, we need to add implicit usings back. This is why I don't use the implicit using. It doesn't really work as expected. Because the new syntax is awful. I don't like it. Come on, let's get out of here. Or we're gonna make a new one. .NET new console, except this time we're gonna use program main. That's much better. Hopefully. There we go. That's the structure I'm expecting. Okay. So now we do publish AoT. Publish AoT. Publish AoT. True. .NET publish -c release. There we go. Now it works. So, if we open this up in IDA, which I forgot to change the installation directory of. Hang on a second. Sorry, someone's knocking on my door. Okay. Yeah, if we check in here, and we actually disable PDB real quick. Not that I need to do that, I could just click no, but you know, you get the idea. Do not load PDB. And yeah, under normal circumstances, where you don't have the debug symbol, this is what it looks like. Which, you know, this is not great. You can't tell what's going on. All of this just looks like mumbo jumbo. Let's first talk about how you can identify whether or not it's a .NET AoT compiled build. So we go into exports. You'll see that it has the .NET Runtime debug header. This won't always be present. You can turn off debugger support, and this will not be there. If we take a look at the strings, there will typically be a few things that stand out to you. First of all, there is the type loader. You're going to see the type loader related element be loaded. You're also going to see stack trace metadata, which this is very important. We'll get to it in a little bit. But you'll see these too, and the type loader. These two are the main things. And of course, you'll see a bunch of .NET related strings. That's fine, but that doesn't necessarily tell you that it's AoT compiled. There will also be process terminating due to Stack Overflow exception. That's also part of what gets compiled during the AoT process. So these are the main strings. And if you look at the sections, segments, well, there's actually not a whole lot here. If we open up this again, we target .NET 8. And we open that up in .NET 8. Once again, don't load PDB. we check the segment, you'll see that in .NET 8, there's actually a bit of difference here. So this is .NET 10, where you just see the standard text section, IDEA section, RDS section, etc., etc. But in .NET 8 specifically, you'll see that there is a managed section and a hydrated section. This is also another way to tell that you're dealing with a section, you're dealing with a AoT compiled application. And you also see that the hydrated section is actually a BSS. So our goal today is to figure out, first of all, how to identify .NET 8 and .NET 10 compiled application, where there are technical differences, and how you can go about restoring the metadata if you don't have the relevant debug symbol. Before that, I need a quick restroom break. I'll be right back. You know, chat, one of the worst thing about wearing a skirt at home, like a long skirt, is that I close the door and it'll get caught by the door. Anyways, let's get back to what I prepared for today. So, if you hate AI, close your ears right now. I'll tell you when to come back, open it back up, like in 5 minutes. I had a long research section. I had a long research session with Claude, and we actually dug through like the runtime repository to figure out how AoT works, and we've compiled a bunch of different tests about how the inner workings of it work, and what we can expect from .NET 8 and .NET 10. Can't you compile a simple .NET app with VB and create a Flirt signature or store at least some function names? Yes, you can, but we don't actually need to do that. We'll come back to that later. That is generally the approach for managed code that gets compiled into unmanaged code. That's the same. You can do the same theory, apply it to Rust as well. But for .NET, we don't actually need to do that because there are details in there that we can restore. And once again, we'll get into that later. Don't we're getting ahead of ourselves here. So, we've done quite a bit of research. This is our main paper we're going to be reading today that I had Claude come up with. Yes, I know. AI bad. But like in this case, it actually really helped me figure out how things work. So, we're gonna skip. Well, actually, you know what? Let's read through both of these together because there are some important grounds that I had to cover as well, such as the reason for AoT in the first place. So, the way AoT works is that it compiled everything that the runtime needs. So that includes the type descriptor, the virtual dispatch tables, like the vtables, static regions, string literals, etc., etc. You need a lot of those data for the .NET runtime to work in general without it breaking, since you don't have the runtime available to you anymore. You only have the basics of what makes the runtime run. And there are a lot of intricacies about how .NET works, including things like reflection and stack trace. So all of this is compiled as native data inside of the P image. And because the runtime needs all of these data to function properly, we can actually reverse engineer and figure out what exactly type of data is stored in there. You might have seen projects like might have seen write-ups on how AoT reverse engineering works in general. Like for example, one by Washi the Goat, of course. Washi has always been someone that knows the .NET internals very well. They also wrote the native AoT restoration plugin. They wrote ASM Resolver. They wrote the string reference feature in dnSpy, etc., etc. And they had done a blog about how the AoT metadata works, which we'll get to after reading the current. Well, we'll switch in between, I think, in between the paper and this blog. Basically, it's what it says here. The way it works is that a bunch of them are stored in or around the RTR section, which is the ready to run header. And the way it worked, if you remember from the .NET 8 application we've seen here, is that there is a hydrated section. What is this hydrated data section exactly? So back in the way it worked is in .NET 8 is that it will find this data dehydration section, and what it will do is that it would rehydrate the data that was in there, and then restore things like the type information from there. And this was disabled in .NET 10, so that's why you don't see a hydration section anymore, because the hydrated data section is not necessary anymore. Well, it's not quote unquote not necessary, but like it's set to default to be disabled now, because in a PR like a year ago, the .NET engineers were like, hey, if we disable dehydration, that actually improves performance quite a bit. Because the data doesn't need to be rehydrated anymore. You don't need to spend the additional runtime and memory footprint on rehydrating the data. So that's why it's been disabled by default for performance reasons in .NET 10. And if we look at how the AoT thing works, right? So the compiler, the ILC, it performs like a whole table analysis, performs a bunch of reachable managed methods in native code, so like it doesn't consider any dead code, and it emits them all to native data. And then it compiles that into something called the ready to run header. It acts as a directory for runtime to consult at startup to locate each region, etc., etc., so that all of the necessary data are created. And all these data are then initialized before main even runs. It's basically like before your main program runs, it has to initialize all the things about the runtime. And if you're doing this at home, and if you try to do a native AoT compilation, you might notice that it won't work unless you have desktop development for C++ installed with Visual Studio because it relies on the linker from the C++ dependencies. So you need to have the C++ development environment, MSVC, installed because it's going to use that platform linker to produce the final PE. So, in short, there is the method table, which is the E type. It carries the type identity, base type, information, interface information, the garbage collection layout, and the inline vtable. And second of all, the one we're most interested in, the human readable information. So the type information, the method information, the field name, signature, etc., etc. It lives in a separate metadata blob that only exists when reflection and diagnostic requires it. So by default, this is enabled through something called the stack trace support in the compiler. This is something you can turn off, which we're going to get to in a little bit. And there's the reflection data. Reflection data used to be something that you can turn off in .NET 8. In .NET 10 does not support it anymore. Technically, you can still do it, but the flag has been hidden, which suggests they're probably going to remove it at some point. Because I think they need reflection. They consider reflection to be crucial or something. That's why that's been kept around. Let's first talk about the data hydration and dehydration process. So, to run the program first needs a lot of different runtime data structures, like the method table, the dictionaries, the static regions, interface dispatch cells, frozen object arrays, all that. And in .NET 8, they're like, okay, that's a lot of data. Do we want them in our application? Because that would contribute to the overall memory footprint and make the program way larger than it needs to be. Like if we compare, for example, if we compare the size differences between .NET 8 and .NET 10, you'll see that there is a significant data size reduction. And the whole idea is that a lot of things have been dropped in favor of size. But at the same time, though, the hydration table, it used to be compressed in here, but it's still larger than .NET 10. It's actually decompressed in .NET 10 as far as I know. Basically, the dehydrated build, instead of telling the runtime, hey, here's the whole thing that we need, and instead tells the runtime, hey, here's what you need to rebuild everything at startup. So before the user code runs, the runtime basically goes through the dehydration process, or rehydration process, and then reinitializes everything that it needs to know. That's the main reason why the hydrated data section is there. And at runtime, this is done through the dehydrated data node. If we go in, instead of relying simply on just what the paper says, we can actually verify this ourselves by going through the .NET runtime code. We're going to go through .NET 8. This section of the code, this metadata manager, I think the dehydration part is largely unchanged from 8 to 10, but let's just look at 10. Let's just look at 8 for now. You'll see that in the metadata, a bunch of things are stored. So that includes things like the reflection-related data. It also includes the dehydrated data, and this dehydrated data node we can see that contains a bunch of different things. So that includes the object data, it includes the Yeah, it's mostly a bunch of pointers. And from here, after it's done all of that, it's going to generate into a dehydrated data. So if we compile this on Linux, if I remember correctly, this is going to be present in the ELF section, I think. I'm actually not sure. I can't really test that on the Windows machine because you can't do... I think you can't do cross-architecture compilation because that requires the Linux C linker, I think. But on Windows, we can see that it's hydrated that section here. And right by default, it should be a bunch of 0 bytes. If we go in there, you'll see that, yeah, there's nothing there. Because this BSS dash section is rehydrated at runtime. And during that initialization, it's going to rehydrate data, and all of the meta tables and whatnot gets rehydrated. And there's been a bit of a change from .NET 8 to .NET 10. So by default, if in .NET 8, I think there used to be dehydrate switch. Yeah, there's a so the dehydrate switch by default is applied to most .NET 8 build as long as you have the control flow guard and whatnot. I forget if it's enabled or not. Condition requires it to be not true. This needs to be not false. This needs to be not guard. So I guess CFG has to be disabled for dehydrate to work. Yeah, there we go. And in .NET 10, this is no longer the case. On Windows, this is actually disabled by default, unless you have optimization preference set to size, where tell the compiler, hey, I want this to be size first instead of performance first. Or when LC dehydrate is specified yourself. And this was changed in the .NET issue here. Yeah, ILC dehydrated is technically undocumented, quote unquote. But after some research, the .NET engineers were like, hey, if we actually disable dehydration, the whole rehydration process, we actually save startup improvement. We actually save startup cost, and we actually reduce the amount of memory used as well. In my testing, in our testing, there was negligible reduction, but like if it's a large application, I imagine there's going to be a bigger saving like this one. Linux and macOS, they still have them by default on, but like on Windows, you know, it's cheap, and so the size benefit just does not justify the startup cost. And so in .NET 10, it also merged the managed code into that text section, and the hydrated section is not there. So if we look in here, you know, we see the typical sections that will be there for a standard PE, like in .NET 8, there was a managed and hydrated section. You no longer see that in .NET 10. Okay, so now let's talk about what's actually being stored. So there is, if we look inside, do I have 010? I do. If we look inside a .NET compiled, AoT compiled application, we can actually see that there is something called RTR. RTR. Do a ASCII string search. It's going to be RTR/0. Yeah. So there's this section that's going to start with RTR/0, and this is the ready to run header. Now, what is the runtime ready to run header? So ready to run was, I believe, an older .NET thing. It's been around forever, but like AoT is quote unquote heavily inspired by ready to run, as documented by Washi. And so many of the structures are actually similar. And this is what the ready to run section looks like. And we can actually see that in the ready to run. There is the ready to run header somewhere. There's the, I know there's a magic around here. Just forgot which one it is. What's RTR? What does RTR translate to? 525452. Oh yeah, there it is. Yeah, this is what the RTR constant is. Yeah, the structure is what is documented there. Looks like that. And the RTR directory contains many of the tag data directories, and one of these sections is the tag 0xcf. If we take a look at dehydrate data, is in here somewhere. Yeah, actually, where is it? Regardless, this is what the dehydrated data section contains, and as you can see, it contains everything that we mentioned previously. So the fixed up tables, the pointers, the compressed data, etc., and rehydrates all of that into a method table. So it gives you something. It gives the runtime something to be able to work off of. And based on everything that's been written here, so it includes the frozen objects and strings, so those are all in the... I forgot if the frozen object and strings are in... Yeah, they are in the RTR section. Sorry, the hydrate section. Based on all of this, Washi was able to write a Ghidra plugin. And someone later ported it to IDA using AI. So there was the IDA native AoT plugin, which is really just a port of the Washi plugin. And so this is what we've learned thus far, right? We know that the hydrated section contains things like the method table, frozen objects, frozen strings, etc., etc. So that is one of the key features that we need to look into. Now, aside from that, that's basically like the gist of how the vtables are parsed and run at startup. Now, let's move on to another thing called the stack trace support. So, if we go back into our code, if we do a raise, what was it again? Throw new invalid operation exception, bad things happened. If we .NET build, yeah, this runs. Okay. And then we do .NET run. You'll see that it's able to tell us, hey, some exception was thrown, and actually told us where exactly it threw. It was able to tell us the class name. It was able to tell us the namespace, the class name, and the method name. So I was able to do all that. That's because when you build the application, it actually stores all of these information in the stack trace method map. So if we turn stack trace enable to be off, I forgot if it's you gotta specify from CS project or we gotta do it in the runtime. Hang on. Build, I think it was -P. Yeah, a second. I think it's down here. I kind of forgot how you pipe this into the runtime. Oh. Yeah, we just specified in the CS project. That's what I thought. Oh. Yeah, flee.net run. Oh, it actually still tells us that. .net clean. Oh wait, it's because it's not running as AoT, right? That's why. If we check here. Oh, come on. Yeah. Turn that off. Yeah, okay, so there we go. That's the behavior I was expecting. So, and when you turn off stack trace support, you'll see that it no longer tells us where exactly the thing's through. It just gives us a arbitrary address that it's going to be very hard to tell where exactly what happened. So, this is where the bulk of what is human readable is stored. If you turn off stack trace support, what ends up happening is you lose all the method names, you lose all the program names. So this would be ideal if you don't need to be reading stack trace names. This would be also something the attacker will probably want to use so that there's no human readable data anymore. Now that's not entirely true because there's still reflection map. Reflection map still contains some metadata that would be helpful, but it'll largely remove things like the program name, the method name, etc., etc. And but before that, before we talk more on that, let's talk about reflection metadata. So the reflection metadata, the reflection data is something that produces the metadata blob, which includes the mapping table. This was something that would generally be required if you need to use reflection and whatnot. If you turn off reflection, sorry, if you turn this feature off, I think reflection would probably just throw, and some of the things would just like break. So this reflection data, I believe, is an unsupported flag in .NET 10. It was still there in .NET 8, I believe. By .NET 10, the property has a zero reference in the build integration. Stuff was simply deleted. Documentation is gone. Yeah, this pretty much tells you that the feature is basically unsupported now. But the reflection data switch is still there and still builds. It's just right now it's quote unquote unsupported. And now let's go back to stack trace support real quick. So in the stack trace support, it basically gives us the method RVA to method token pair. So in IDA and any disassembler, you can parse the blob that's in the stack trace metadata support, and you can rebuild the RVA, the method name to RVA mapping. And we can actually test that right now by installing this plugin. Pop that into our IDA user. Just close out this real quick. CD hello world. There should be a way I can tell it to output to somewhere. -O, that's it. Okay. Oh, we want to do .NET 10 actually. So this is with the stack trace metadata on. We're not going to load any symbols. We go into plugins, native AoT recover. It's going to be like, hey, finish all that. Where is the window? Where's the AoT window? What? It's supposed to show us that. Oh wait, this is the wrong version. Oh. That's not a plugin I wanted to install, actually. The one I want to install is from the the dump guy. Yeah, that's it. Cool name. Alright. That means we need to delete. We just installed. I prefer this version because it has a little browser you can use. Okay, so we go into plugins, native AoT metadata browser. Okay, this browser actually tells you, hey, it's probably .NET 10, and it's able to recover some of the function names. So, for example, we go into the various types. Sorry, everything is a little bit big because I need to show you guys the text and whatnot, you know. Anyways, yeah, it's able to recover some of the classes. I think the other plugin actually recovers more, so this plugin is not ideal. But you know, the reason why I like this is because you can also see the method and whatnot from here. But unfortunately, they don't recover the names. Now, if we open this up in get rid of these, get rid of these. They're really in the way. Not you. You. You'll see, by the way, we got some size deficit back when we turn off stack trace support. Yeah. We use a plugin again. I was able to recover some of them, but I believe, yeah, there are fewer method names and method in general it can recover. I wonder what difference it will make for the other plugin, because I hadn't used that other plugin before. Let's install it real quick again. Run this again. New IDB. Yeah, there are far fewer types. Well, I wouldn't say far fewer, but like fewer types that can recover. We check in the strings. You also see things like that's actually not quite what I expected. But regardless, you can see that some of them are not available anymore, and that some of the metadata cannot be parsed and not quite covered. And I think the main reason the plugin is not as phased, it's still phased, but like it's not as phased, is because it mainly parses the hydration section, which by default doesn't really exist. I think it falls back to for .NET 10. I think it falls back to scanning the addresses. Give me a second. I'm just devouring all these bottles of water. So keep in mind, this is something I mixed up a lot during my research. Is the hydration section is completely separate from the stack trace metadata support stuff. So they're not of the same thing. The things handled by the dehydration process are the v method table, the v tables, the type identity, string literals, etc., etc. So technically, if we do .NET 8 now, okay. So I believe when I use this, oh, by the way, you can see the RTR header matrix is slightly different. Well, not magic, the version number. Yeah, there's still far fewer methods and types that can be covered when you turn stack trace support off. I also want to see how this does. By the way, this is what the vtable looks like. You'll see the reference to the class and the relevant methods they'll be calling, or the members they have, rather. Now, here's what I'm more interested in. If I turn on dehydration, is it going to affect the results? So here's what I want to try. If I turn on dehydration, show me the CS project, please. So we can just copy paste. Why is it lagging? What are you doing? What are you doing? Windows, please. Quiet, please. Ow. Stack trace off. LC dehydrate on. Yeah. Hydrate. I just did. So if we do this now. Download PDB. We do this. Okay, and we compare that to this. Yeah, there's a considerable difference. Huh. Well, no, there's not, actually. Both recover the same amount of strings and types. But why is the layout look so different? Huh. Ow. What happens if I turn reflection off now? There's a new version of 010? What? My ADHD is working now. What did you change? Ah, minor bug fixes. Oh wait, what? There was an update since. I've been using the older version since. Oh wait, that's V16. Oh wait, I do have V16. Why do I have V15 installed in here? Oh. Anyways, that's just because I have an older version installed in the VM. What happens if I turn off reflection support as well? do that right now. Turn this off. Looks about the same. Oh, no. It's actually smaller. So, if we turn off stack trace, rehydrate on, reflection off, that seems to give us the smallest binary. Which makes sense, of course, but... it just throws unhandled exception with no address. Huh. So it can't even give us the name of the exception. Okay, what happens if we run this now? Okay, so there are fewer types once again. What if we build something more complex? I'll just steal this code from Claude. See what happens. How do I supply an item group? From CLI. It's been a while. Like I said, it's been a while since I last wrote C# or .NET in general. Give me a second. Item group. It is /p, but like, that's a property group, isn't it? If I did that. How do I pass item group property group options? I built okay, so you can't specify item group specifically. You can only specify property group. That's annoying. My computer's lagging because of how much stuff is running right now. Oh wait, I forgot to save. Seems to take a little bit longer to run with stack trace support on as well. Wait, what? Oh, yeah, that's more like it. Okay. So that does still result in the smallest file size. Let's open all of these in IDA. Overwrite. Overwrite. No. 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 Overwrite. Overwrite. My taskbar is being filled. At the cost of making things look presentable to you guys. I had to, not you. I had to do like 200% scaling. So everything looks like it's all crammed together. Okay, so there are a few things I wonder. So first of all, what does this look like when I run them? Yeah, I get it. So if we run with stack trace on, that runs. Stack trace off. An address. Dehydration, that shouldn't matter. Yeah. Yeah, if you try to do reflection, it just froze. But if you don't use reflection, Theoretically, this would result in fewer things that can be covered. Okay, so one of them has like significantly fewer types. That's like way fewer types. Slightly fewer strings, just slightly. But the main thing I want to know is, was it able to recreate the widget class? So, just a reminder, these plugins don't actually seem to parse the method to RVA. This is something we'll get to in a little bit. So, as expected, the widget doesn't show us anything like that. Sorry, the plugin doesn't show us anything like that. But I'm also curious about, for example, the strings. Do they make a difference here? Do I have... I didn't. That's why. Turn those back on. So all of them still has a string. Hang on a second. I need a quick restroom break. I'm gonna go turn the AC down as well. It's getting hot in here. Be right back. Alright, that returned. Took a little bit because I had to go get extra bottle of water. Okay. There's something I'm interested in. Okay, here's an interesting observation to be made here. You see how the widget instance is gone? In the reflection off build? Is it because it's considered a non-reachable code? And interestingly, it breaks before the type of call can be made. Because it doesn't even print the type of name. It just blew up. I mean, theoretically, if your applications are simple enough, where a reflection doesn't matter in any way, including the fact that you don't even use any of the type of statements, maybe this would help. But I feel like that would be too much of a risk. If we take a look at these section tables, Shift F7. No, that's F6. Actually, none of them generate this hydrated data section. Oh, you have to turn off merge sections as well. What if I turn that on now? What does that look like? That would theoretically be bigger, right? No, it's the same. Okay, but I guess it just splits it off, so like technically there's not a difference? Okay. So wait, what happens if I have this section now? And then run the recovery? think the native AoT plugin is actually using Flirt. Hang on, let's check. That might explain why it's able to recover the sections. Yeah, it's using pre-built Flirt signatures. Okay, having the split section doesn't really matter, it seems. It's making the assumption that dehydrated data would make string recovery more difficult, but is that really true? I mean, they're both present. Just in different sections. When dehydration is on, it also shows up in our data. Okay, here's another thing I want to take a look at. Let's figure out if we can do name mapping to RVA, or the other way around, RVA to mapping. So, I have this lab presented here, and our goal is to follow this without checking the solution. So we have a hello AoT. I think that was built with, we're gonna look at the source. We're not gonna look at the source file, but we're gonna look at the project file. So stack trace support is on here. Publish AoT is on. Okay. We're not gonna see the ground truth. And we're just gonna start off as any regular. File here. Yeah, shh, quiet. And we can identify this by checking the... Well, first of all, the type load information is there. So, stack trace metadata is there as well. You know, speaking of, do I have that in the... my PR? Sorry, excuse me. My PR? I don't. I think I can add that, actually. Actually, let me do that real quick. .NET AoT. Stack trace metadata. Two or more. Okay, I think that's a little bit more appropriate. Git push fork. Okay. Yeah, I moved it into, I added stack trace metadata and moved it into its own OR section. I think that's a little bit more appropriate. Alright, anyways, back to this. So right now, there's not a lot that we can work off of. We can use the AoT metadata browser. You can also use now use that. Yeah, as you can see, there's not a lot that was recovered. We don't know what's going on. We can see some class BCL class names. We can see some vtables. That's about it. So our goal is to see if we can somehow recover the program names. Right now, there's none. We don't see anything. We don't see a program main. We don't see a program, quote unquote, anywhere. We might be able to see a program from here. We can see that there was a program, quote unquote, program here. That's in the that's presented in the raw string, but that's about it. We don't have a direct mapping from all of this to the RVAs. So our goal right now is to see if we can do that. So, let's take a look at what Claw was able to cook up. Oh, come on. Chair's stuck. Try one newfangled, expensive ass chair. I just have a regular office chair. Anyways, so the triage just shows us basic PE information. Okay. There might be a... No. What does triage give us? Yeah, it just tells us, you know, what's been imported. The only thing that really tells us that it's not an AoT compile is based on this export name. If I load this into dnspy, lspy, it'll just tell us that it's a regular PE, that there is no disassemblable IO code in there. Run the plugin. Does it say dehydrate data or manual scan? I'm pretty sure it's going to give us, yeah, manual scan. Yeah, it just gives us a bunch of generic method and class names. Like this. Which doesn't tell us much. So our job is to check the RTR. What is that in hex? Hex? Yeah, there we go. So what it does is it parses through, it goes to the RTR section. We go into here. Yeah. RTR. Close this. That's a runtime ready to run header. So it's trying to find. Yeah, okay. It found the header. It's gonna parse from the headers plus 0x0c. We use Washi's thing as a reference here. We could also just look at the .NET runtime source code, but this is easier. X04, X2, 2. I assume it's looking for a number of sections, hence unsec. What's ENT as Z? Oh, entry size and entry type. If the number of entries is less than 0x50 and the entry size is 0x18, okay, so it's trying to parse the sections in yeah, it's trying to parse the sections in RTR. That length does not look correct. God damn it, that's not what I meant to do. And where's this called? I assume the type is recorded somewhere. We're just gonna look at the .NET 10 one instead. Class code is that? What's object order node order? What? Where's grabbing on? Where's it grabbing that? This? Oh. What does that equal to? I assume this starts from 0. Like any other enums. I don't think this is correct. I think it screwed up this part of script. Says it'll find that, but I didn't see any. But I think it's fine. As long as you have to start RVA and whatnot, we can just brute force it. Yeah, let's see what this gives us. Okay, so it was able to give us all of the type names. And how did that work? Ah. Just did regex. Or did it? So it's actually looking at section 327 and 313. If you want to look at it dynamically, CR has a ton of interesting tracing features. But do you even have access to that in the AoT scenario? Okay, so it was rebuilding it from those two sections in RTR. I think it's limited in AoT. We can tell Windows to create any CLR, including reflection stuff. I don't think you can, though. I don't think you can override that in AoT, because it's all, the runtime is contained in the AoT. It's all compiled natively into instructions, native instructions. All right, let's take a look at the names here. So we see that there is the Hello AoT greeting service, build greeting. So it has to rebuild all of that from the RTR header. Or sorry, the RTR section. Let's take a look at dump oracle arg. Okay, we're not gonna apply the IDB. We're gonna skip that, because that's where the ground truth is. Let's try applying the name. Apply names. Right. We have to do that through, because it applies through the IDC, arg. We will either have to hardcode that, or we are gonna have to run IDAT. Fine, I'll run IDAT. It's probably easier. Is the IDAT even supporting it? Okay, I guess still it is. I thought he dropped it. not you. Oh, God, get out of here. No. Dot invoke. What? Why would it fail? Oh, it's fine. I'll just do this. Just call it inside IDA. That's easier. Oh. Right. Okay, so now we have an RVA to member name mapping. So now we went from everything being non-named functions to named functions. So now if we go to yeah, what was it again? Greeting service. Okay, so now we have some idea of what we're looking at. That is probably... Yeah, that doesn't help me. Hello. Yes. Okay. So it was able to do that through stack trace support. So I want to go back to our minimized build, which is the stack trace off. Let's use this one, right? And then we'll try emit names. And that's going to give us 0 names because stack trace support is off. And if we do that on a stack trace on build, that's going to be there. Okay, so what we learned thus far is that turning stack trace support off will not give us any recoverable RVA to member mapping. And you're just kind of screwed. With that being said, I think the flirt method would still kind of work. You're able to at least recover some of the BCL stuff with that. So if we generate a flirt signature from this, yeah, just do stack trace support off. And then we .NET publish. Oh wait, I need the AoT as well. And then we generate a flirt based on the PDB. Oh, thank you for follow. Welcome to stream. By the way, I kind of appreciate that the function names actually get folders now. That's kind of nice. Produce file. We'll create a signature. Okay. And then we apply it to a stack trace support off binary. We're gonna override it. Do not load PDB. We'll run a little bit. Okay. And then we do this. And we also apply native AoT recover. And then we load the signature. How much is this able to give us back? Okay, that's a decent amount. So it seems like the flirt method is still the main way to go. If you somehow don't have... Okay, so let's run this down. Stack trace support off. You're fucked. Use sig. Stack trace support on is the default. Rebuild from stack trace method mapping node. right? You should still have some mapping, though. Yeah, so you don't have canonical method names, but you still have Why am I using a notepad for this? I should just use this. Okay, so reflection shouldn't matter, right? Because like stack trace support is like our biggest win for RVA member mapping. What's the arg again? Reflection data. Okay, hang on a second. I need a quick restroom break. I'll be right back. All right, I'm back. So, I need a quick reminder. So, method tables contains the string literals, type identity, etc., etc. So vtables, those are all also governed by dehydration. The reflection metadata, though, also contains type, method, field names. So what happens if we build a normal build that just has reflection off? Yes. I cannot spell. Stack trace on. Off. Reflection off. It's still able to emit names because that's not... The names are not governed by reflection metadata. However, the type information might not be there. Is it going to have trouble reading that? I don't think it will. What's level 2? Yeah, it doesn't seem to matter. This shit too complicated, just code in Java, bro. I mean, it would be nice if all the malware developers just start writing Java. I wouldn't have issues with reverse engineering them. just pop into a jar decompiler. Reflection data off. I mean, hang on. Can we check the repo real quick? Reflection metadata. I want to see what exactly got changed. So if I remove... No, not you. Get out of here. You. That's just like the default. What are the differences between the two exactly? What specifically is missing or added? That's on, that's off. Wait. Let's close all these. I want to see the reflection on build. So this is off, this is on. Huh. The member... The backing field is slightly different. The backing field is, for example, when you do a get set, internally there's actually a get and set method for each of them. So theoretically, if you want less stuff in the binary, like quote-unquote maximum stealth, you can turn off reflection data. But that will most likely break things. It's generally not worth it. And the most important information for reverse engineers are probably the stack trace support anyways. So realistically, if you want to give us a hard time, then turn off stack trace support. That's like the biggest change, I would say. Does type of break? I thought that was compile time get type of problematic. Yeah, so for some reason it seems to do that. I'm not really sure why. If we take a look at... Right, so this is our code. We did a type of at start, and in theory it should print type of name, right? If we go to a reflection off build, like this one, yeah, it just breaks. It just throws. I'm not really sure why. I don't really know what the implementation of type of is exactly under the hood. And I'm not really sure what exactly reflection support removes when it's off. The reflection data, rather. And besides, it's also, not officially supported in .NET 10. Can you compare types successfully instead of trying to retrieve the name? Yeah, let's try that. If I remember correctly, I want to double check. I don't want to make a fool of myself. C#. Because type testing has changed quite a bit. Because there's an is, there's an as. Been a while since I last did this. Give me a second. Yeah, I should be able to do something like if one type of int. Or type of t equals type of int. Yeah. I mean, this should also work though, right? Remember correctly. Oh. Right, because it's, yeah, we need to do, yeah. There we go. Oh, wait. Yeah. One dot get type. Wait, that should break, right? Because it's get type. Can you tell it's been a decade since I last wrote C#? Because I usually just do is or as. Sorry, is and then or as is a save typecast. I am stupid. Give me a second. Yeah, so if we do like a var int 1, and then we do a type of int 1, right? Does that work? Okay, you know what? I'm just gonna ask. It's been a while since I last used type of. Oh my god, can you stop breaking? Shh. A case with generic class? Yeah, I suppose I could do that. Hang on. But realistically, the type of keyword, hang on. Do I have the full runtime here? Would that fall under, no, that would fall under the C# language repo. Right. There's the runtime repo, this doesn't have that. But in theory, this should also perform the same. Because it's going to invoke type of anyways. If we remove this line, and then we build it, hang on. Turn that on. Oh wait, reflection off. Reflection off. Yeah, that also breaks. Just double check. Yeah. So it's not even because it's trying to retrieve the name. Alright, we'll try it. We'll try that. I'm gonna do a constructor. Oh wait, if. Okay. And then we do a, it has to be an int, right? So you gotta do it like this, right? So that should get invoked on constructor. Well, I should probably... Okay, so that works. Yeah. So type of technically works. Just not really sure what's causing the crash here. I mean, not that it really matters in this case. We're not looking for... Oh, okay, this is misleading. Sorry for the random rabbit hole. No, not really. I mean, we're here to learn anyways about if any of this breaks anything. And yeah, like I said, reflection data is technically not supported anymore because the relevant documentation actually got removed for .NET 10. So I assume like they're just gonna keep it as on, not really change it. I have a feeling this flag is gonna be gone at some point. Okay, so what we've learned is, once again, let's are we concluding? I feel like we're concluding, right? Because like I think we've looked through everything. Oh, actually, you know what? Let's look through this real quick, actually. So yeah, this part we don't need to read about this. Can we do a render of this? It's like, this is really annoying to look at. Markdown. Yeah, that's better. I don't think that's true. because that data is still gonna be in their stack trace metadata. Type name method field names should technically still be in the reflection metadata. The stack trace metadata, because we compiled it with it off, stack trace metadata on, and we still got the type method names, right? Oh. Stack trace support true, reflection off, which should be this anyways. Because if that theory were true, then the Python script would not have been able to grab anything. All right. Hello world. Yeah. I don't think it would follow. Yeah, that still gives us the type names just fine. So that shouldn't matter. I don't think this is quite true. Oh yeah, by the way, I want to try compiling with this on. Let's try that. Turn this off. I want to see what this map file looks like. Huh. Well, that's helpful. I don't know if this is necessarily any better though, because like by length seems kind of weird. I feel like you'd be better off just reading the source code and then figure out the enum ID instead. Yeah, I did notice there was no program main, because I got inlined into the same method. So not every single program name you expect or method member will be in the final code. It's interesting seeing these internals. I've never looked much into the side of .NET. I just deep dive performance. Yeah, it's the other way around for me. It's been a long time since I last wrote any real .NET code. I used to. Not much anymore. I used to help write a few things like Discord.net. But these days I'm just like, yeah, I don't really do this anymore. I look at malware for the most part. So it was earlier this week that I ran into a AoT sample. It's not the first time I ran into an AoT sample, but like there were a few things I didn't understand or didn't come to expect in AoT samples. I was like, huh, this looks strange. And it turns out it's because .NET 10 changed quite a few things. And that's why we're doing this stream, because we want to figure out what's going on. Also figure out how reverse engineering .NET AoT specific things work. AoT is still a very dynamic target. Yeah, I've noticed it's changed quite a few bit. So the main thing is that the fact that the hydratable section, the hydratable thing is turned off by default now for Windows. That's the biggest thing I've learned. Okay, yeah, maybe I should have read this part earlier. Okay, so type of technically still works. Just getting names and whatnot, that's gonna break. Yeah, that makes sense. So really, stack trace support is like the safest thing you can remove if you want to annoy all of us. Well, yeah, the whole dehydrate thing being set to false by default was the biggest thing for .NET 10. Actually, .NET 9. I think it started from .NET 9, actually. Do we have the RSP? Oh, we do. I was gonna check what linker options that would give us. Can I technically put /repro in here? Can I add additional RSP options? Hang on. Well, I guess I'll ask Claude. Because I don't know if you can override options like that. No. Of course, Fable 5 doesn't want to answer. Of course, it never does. Linker arg. Oh. Oh, I didn't know you can specify pinvoke into the project. Huh. Oh, you can add a linker. Okay, so what happens if I... It's item group. Yeah, item group. What if I do this? Does that work? Oh, it did. Okay, what does that give us? Ah. Okay, so you can even further quote unquote strengthening your, well, that still gives us PDB though. I think you can also tell the, is PDB handled by a linker? Or is that gonna be before the handoff to a linker? I think that's during the linker stage, right? Native debug symbols. So you can technically turn it off in both layers. So if we do native debug symbols, false. And debug type none. And slash debug none. We'll add that later. Let's just run this. Also, let's get rid of this. Turn this to off, false. What does this look like? Oh. Okay, did not like that. Oh wait, it's because I have these on. Oh yeah, that's why. Try that again. Okay. Okay, so the pogo is the PDB in the pogo is gone. But I think pogo might still give us a compilation date. Where's the output window? No. I'm just gonna reset all talking. Hello, where's the template window? Oh. Okay, so if we check the debug directory, okay, that gives us a reproducible timestamp. So that also doesn't give us. So that still gives us the executable name, but that's not handled by the linker anyways. What if we turn this off anyways? Does that change anything? It shouldn't, because there's no... That PDB doesn't get generated anyways. That shouldn't matter. That's still the same size. Yeah, it doesn't really matter. I think you can also turn off debugger support. Yeah, so if we do this... and then do this. So the export header is also now gone. Okay. Huh. So this is a bit of an edge case. Do the strings I expect still are they still present? So these should still be there. That's no problem. Yeah, so reflection.execution, that's still there. Stack trace metadata, that's not going to be there because I turned it off. Actually, well, we're going to keep that on. Type loader, that's probably still there, right? Yeah, that is. So my rule will still work on this. Attempt unmanaged callers only. Yes, that's still there as well. That's still there as well. Okay, so my rule for detecting AoTs should still work, even on this quote-unquote strengthened build. But let's say for some reason, for the sake of the argument, let's turn off reflection support. Let's just say my program is so simple that it doesn't care, it doesn't need reflection data. Because, you know, if it's a simple hello world, by the way, I wonder what if the Pogo directory is required at all. Swear to God, if I ask Claude Fable 5 anything, it just tells me, hey, stop it. And downgrades me to Elpis. Oh, thank you for a follow. Some new viewers today. Because, like, Pogo directory should be a debug entry. That shouldn't be required. So can I get rid of it? Here on my YT homepage. Oh, thanks. YouTube recommendation doing this job. Yeah, I've noticed whenever I do these REWorkshop streams, they get recommended. Which is nice. I just don't do these very often though, so don't expect this to be like a weekly thing. It's more like whenever I feel like it. My computer's freaking out, by the way. There's too many VMs running. I keep seeing OBS telling me, like, hey, calm down, please. Sorry, I'm looking up documentation in the background. The no cough. What am I looking at? No cough GRP info. Okay. So technically, I should also get rid of the Pogo. So I'm gonna change this back to like a simple hello world for now. Void. Okay, so no more Pogo directory. Not that it really matters, but it was optional in the first place anyways. And this should, in theory, still run. Yeah. Strengthening. The words look so weird to me. So we can turn on brepro via linker arg. MSVC linker is used to build the final P. So linker, additional linker arguments can be used. Like the classic brepro. What's the goal? Are you trying to detect LTEXEs regardless of the build config? I mean, kinda. I mean, so I'm not sure if you were here earlier, but we kind of done our goal already. Our goal was to recover member name mapping for a known executable. Right now, what we're doing is just we're wrapping up. I'm just telling people like what are things they can do if they want to give us a hard time. I just joined, so I missed the first part. Yeah, I mean, I think I can show you what the whole thing is about. So, like, for example, I'm just gonna delete all this. So this is what this would look like to us. If we just got a new sample and we have no idea what's going on. There's like nothing recognizable in here, right? We could use maybe AoT recover to give us some BCL names back. So got the general base class library stuff. So like the exceptions, general system namespace related stuff, console related stuff. And we could also use the metadata browser if we want to get really deep into it, but generally this is not required. But the main thing is, well, we have all the BCL stuff. That's great and all, but like, I want to figure out where the quote-unquote possibly malicious stuff is. In this case, it's just the hello world. But like, let's just say this is malware. Where do we even start? Because like, you know, it's just giving us BCL. That doesn't really help us. So, in the stack trace, by default, .NET builds the AoT targets with something called stack trace support. If I hadn't specified this would be true by default. If you turn on stack trace support, which is default, it's going to give you the method names, class names, type information, etc., etc. and that's going to help us remap the member names to the function names here. And it's basically a token to RVA mapping. And to do that, a little script here. We can omit names. TSV. Omit. Okay. And from doing that, basically what the script does is it parses through here. It parses through the stack trace metadata section, which is currently under 327, 313, the ID of which you can find under the object or node order. And here you can find the stack trace metadata mapping node. It's able to find that, and it's able to parse it from there, and it generates a mapping. So like, see the export name, we'll see that, hey, here's all of the member names that were present in stack trace metadata. And the left side is the RVA. So if we run this, run apply names, you'll see that, hey, all the non-blue stuff, the blue stuff was or the member names are recovered from her flirt signature. All the non-blue stuff now has a name as well. So now we have all this. And now we know we are looking for a greeting service. And this is what it gets called on run. We can take a look at our ground truth for reference. As you can see, it just writes hello world in a very complicated manner, also because it also prints a tick time. It also gets a date time now, and then it appends it into a format string. Yeah, this is a lot more readable than having nothing. Because like, you know, if I didn't do any of these would just be like generic sub-routine names, and be like, okay, I have no idea what I'm looking at. So that was the goal of the stream at the beginning. And no one's built a tool for this yet, so I feel like this is something that can be incorporated into existing native AoT plugins. I don't really know how I would realistically incorporate this across .NET versions though, because like right now the script is really geared towards .NET 10. But yeah. Anyways, let's get back to our conclusion stuff. Okay, so this is our conclusion. Stack trace support on default. That means we can rebuild it from the mapping node. That means we get the ground truth mapping name. And you can also use a flirt signature to build a relatively close binary if you can, and then apply that signature, because that also works very well, especially against BCL stuff. Now, if you have stack trace support off, that means, well, good luck. You have no author names. You have no canonical name for the program names, which is not great. We've also found that the LC dehydrate on or off technically should matter. It handles the vtable and frozen strings, but those are handled by the native AoT plugins anyways, so it's not a big deal whether it's on or off. Reflection data off theoretically should remove type, method, field names. I have also noticed that it seemed to remove reflection mirror specific blobs from the binary. But the return on investment is relatively small. Yeah, because anything reflection related will probably break and crash, and it's not guaranteed to work very well. And that flag also got kind of hidden in .NET 10 anyway, so it's... Thanks. That's what I get for putting my bottles next to me. Anyways. Since we know that AoT also uses the MSVC linker to do its final build, so for reference, if you want to build this at home, you're going to need to install the C++ MSVC development environment through VS Installer, so it can use the link.exe to do the final building. And because we know it uses a linker, the CS project also supports piping in extra linker arguments through linker_arg. So you can put in the classics like brepro, which turns on reproducible build, which turns off the timestamp that gets written. It's now a hash instead of a date. You can also turn off pogo generation. That doesn't really matter. It's just a large blob that's just there unused. It also gives extra clue as to whether or not this was compiled with brepro, because the hash is going to be the same in the pogo debug directory. That's not really needed, so I'll just turn that off if you can't be bothered with it. You can also turn off debugger support, so that way the generated blob will not have a .NET runtime debug header in the export section. So you can turn that off. PDB debug generation, you can also turn that off because by default it's going to generate a PDB for debugging. You can also turn that off, so you can so the PDB path will not be present in a final build as well. That will prevent any local directory path name exposure. So yeah, that's all of that. You know, I was kind of expecting today's stream to be a little bit more in depth. In retrospect, I think I definitely prepared a little bit too much, because like realistically, right, I did peek at the .NET runtime source code, but it's not like you want me to understand all of these. Probably not very realistic, but I can at least we did make some use of it by looking through like where the enums are stored and where everything is, which by the way, these references have really helped during the research. If you're interested in doing this at home, look at all these relevant ground truth source code at .NET/runtime repository. And also just read Washi's blog, because that also gives you a good starting ground on what this whole thing is. All thanks to Washi for doing the initial work, actually, because you know, a lot of the plugins we have now is based on theories and things that Washi learned from reverse engineering AoT. I want to go round back to the initial question that was posed earlier in the stream, in the chat. Someone asked if it's possible to just like build a thing and then have it generate a flirt signature and apply it. Yes, but that would generally will only apply to BCL and or the relevant libraries used, and you have to pin down the exact version they're using, which is not something, the version number is not something that is recorded in the AoT build information, I believe. So you won't even know exactly which BCL version they're using, which library they're using. For example, if they're using SSH library, right? You have to guess which SSH library they're using, which version they're using specifically. Otherwise, you'll end up with like a flirt signature that's kind of useful, but also not really. Because first of all, there's a chance of false positive. Second of all, though that's really on the lower side of chance, because all the functions hashes are very different. Anyways, the main thing is that you probably won't be able to identify many of them. That being said, I think a flirt signature definitely helps. So if you can be bothered to do that, that is an option. The same goes for Rust as well. You can also do something very similar with Rust. That is generally how Rust name symbols are recovered. You compile something very similar, because in the Rust library, you can instead of how .NET, you have to kind of guess which libraries they used, which version they used, which the version number is not printed in anywhere in the AoT build. On the Rust side of things, that you can actually list out all of the libraries that were used and all of the version numbers they were using. And so you can technically build something very similar and then have it build a object that contains all of the library information and names, and then generate a flirt signature from there and apply it. So in that way, the same idea works for a Rust as well. I think it might also apply to Go, but I'm not really sure. Okay. With that being said, I think that's all about what I want to go through today. I don't know if I'll release the code for this though. Because this was generated by Ida. What is that tag doing in your description? Don't worry about it. Anyways, let's see if we can find someone to raid. It's at a weird hour though. I'm not sure who's up. Let's see. Well, Jolly's streaming. We're Jolly. Sip. I'm out of water. I don't have anything to sip. I got like one. Here you go, one drop of water. Okay, I'm gonna send you guys off to Jolly, and have a good night, everyone, or noon, wherever you are. It's currently 1:40 p.m. here. All right, I'll see you guys later. Good night, good evening, good noon, whatever. Bye bye.